Now, once you start tunneling, there's also the following dangers that can occur. Now, your top wall has a tendency to break down and collapse if it's not supported. The side walls have a tendency to fall inwards and collapse. Now, I'm not going to draw it like that. What I'm going to do is make a breakpoint in here. This is how your tunnel can cave in. Now, the best structure to build a tunnel is actually, and the best example you can see in a tunnel like in the Mont Blanc, that is actually a design like this, where it's not a full circle, but kind of like that. Why is that such a strong structure? Well, because the pressure that goes in here is being deducted slightly towards the sides. Also here, this wall is being supported like this, so there's less chance of collapsing. Because if you think about structure, let me give you a different example. The strongest shape within all kinds of structure is either circle-wise or triangle-shaped. Now, say you have a wall. You can actually test this by yourself. Okay. Trying to make a good drawing here. So usually when they mason a wall, you're going to do it in that type of connection. And this is also for load-bearing walls the idea. If you take away this brick, what's going to happen is this brick is, this part wants to fall down, but then again, because it's been clamped in here, there's a structural support like this. So even when you take down this one brick, nothing's going to happen with your structure. Now, if you're going to take away two bricks, say these two here, what's going to happen is there is in this line still a supporting structure, and there is in this line still a supporting structure. Now, the real danger is going to be in this brick, because this brick is just hanging by its structure, by its mortar. So this brick has more the tendency of falling down or collapsing. And this is how you have to visualize your tunnel. As long as you work with evasing lines like this, there's more chance that your tunnel is going to support. Now, of course, if you're going to work like this, and then you're going to build your tunnel support like that. So let's say this is not bricks, but this is your ground, this is your soil, and you're excavating like this within a line like that. Of course, what's going to happen is, if you're gonna, I'm just going to draw it neatly for you so you can also follow along with me. So these are the supporting structures. Now, whenever there's a chance something wants to fall down, here you have a small momentum. So if it's going to fall 5 centimeters down, there's slight chance that this is going to break. But of course, if this one is 50 centimeters falling down, there's going to be more momentum. And of course, the faster something goes, the more impact it's going to have. So if you're going to make a gap like that, it's going to make more damage here or even break it. So that is why we have to keep our risk analysis in mind that even though we're gonna dig it straight here, this triangle shape might fall down. And that's why the supporting structure has to be as close as it can get to the ceiling. And that's why in the later steps you will see that if you would look at my plan, that I try to work with the arch to compensate with it. But these are the basic, this is the basic idea about how the top wall can cave in. Now, of course, I'm not an engineer. If there's someone in the comments who has a very better idea about this safety hazard, you can always comment it and I will keep it in mind and maybe even make a new video with a new statement or a new update about the safety issue.